Hello, Math 006. This is 7.1 and 7.2 review. These examples have all been pulled from your notes that I gave you before spring break. You can find them on Play-Doh if you do not have them with you. Everything that I'm going to be working through in this light blue is going to be from 7.1, and we switch over to this orangish color, that's going to be everything from 7.2. So feel free to get your notes out and follow along. So the first example is find all the numbers for which the rational expression or function is undefined. We want to remember that undefined means the denominator cannot be equal to 0. So what we want to do is take the denominator and let it be equal to 0. So x squared minus 3x minus 28 equals 0. To find which values would make that 0, we need to solve this, or we want to factor it. So we want to start by factoring the left-hand side of this. So we know we have an x and an x, and then a negative 28, well, we'd want to use negative 7 plus 4. Then we use the principle of zero products to let each of those factors be equal to 0. And then on the first one, x minus 7, we add a 7 to both sides to get x equals 7. And on this one, we would subtract a 4 to get x equals negative 4. So here, this function would be undefined at 7 and negative 4. Now looking at the next one, just do a line in there to separate them. Now this one we have a function f of x is equal to x plus 2 over x squared minus 4x. Again, we are just focused on when that denominator is going to be equal to 0. So we take x squared minus 4x equals 0. And again, we have to factor this. We see that both of those have a common factor of x, so we factor that out. And then we're left with x minus 4 equals 0. From here, we set each factor equal to 0. So we have x equals 0 and x minus 4 equals 0. Well, this one's already solved for 0, so we know one of our values is going to be 0. Then if we add 4 to both sides, we know x is equal to 4, so 0 and 4 would be where this function would be undefined. The next examples that we're looking at is going to be simplifying these rational expressions by removing a factor equal to 0. First thing we have to do with everything here is factor everything completely. We can see this numerator of the first one, they all have a common factor of 2. So we want to factor out a 2, which leaves us with n squared minus 3n plus 2. And then the denominator, they both have a factor of 6. So we get n squared minus 1. Now you'll notice that the trinomial on top and the binomial in the denominator will both also factor. So we have 2 times, and then this would be n minus 2 times n minus 1. And divide that by 6, and then n plus 1, n minus 1. So then we just want to cancel things. Well, we see that they both have an n minus 1, so that'll cancel. And we can also rewrite this 6 as factors of 2 times 3, and we'll see that the 2's will cancel. Therefore, I squeeze this in here, we're left with n minus 2 over 3 times n plus 1. And then in number 2, the numerator is already factored. However, the denominator, we see that we have a common factor of 2, and it's also written in the wrong order. So we're going to rewrite it in descending order. So I'm going to rewrite this as negative 2x plus 6. Now we'll see that, let's write this a little bit nicer. We see that the leading coefficient of the denominator is a negative, so we are going to factor out that negative. So we have x minus 3 in the numerator, and then we're going to factor out a negative 2, and then we factor out a negative 2 there, we're left with x minus 3. And you can distribute that to make sure you did it correctly. And then we can see that the factors of x minus 3 cancel, and we're left with a negative 1/2, because we know there's a 1 left in that numerator. The next example we're looking at is writing the simplified form for the function. We want to make sure we list all the restrictions on the domain. So we need to look at two things. One, we have to simplify it. We also have to list which values would make that denominator equal to 0. First thing we're going to do is go through and factor the numerator and the denominator. We know this numerator, since it's a trinomial, we can see that this will factor into x minus 4 and x plus 1. And the denominator, we know this will factor to x plus 1 and x plus 8. And here we have an x plus 1 in the numerator and denominator, so we know they factor, and we're left with the x minus 4 over x plus 8. So that's going to be the simplified form, so we can rewrite that as f of x. However, we have to also list, that was supposed to be a semicolon, we have to also list the restrictions in the domain, but if we look at this whole denominator, we could apply the principle of zero products at x plus 1 equals 0 and x plus 8 equals 0. And when you solve both of them, you can see that our restrictions would be -1 and a -8. That pretty much summarizes all of 7.1. So I just want to do a couple quick examples from 7.2 to review our memory from those. 7.2 is mainly multiplying and dividing rational expressions. I'm going to do one multiplication and then one division, and that should finish up this quick little video. So what we have to do first to multiply and simplify, remember multiply, you multiply straight across, but what we want to do here is we want to make sure we factor everything first. So the first numerator, 2x plus 2, we can factor a 2 out and we're left with x plus 1. The denominator, we can factor an x out and we're left with x minus 1. And then we have to factor the numerator and the denominator of the second one. The numerator, we can see this is going to factor into x minus 1 and x minus 1. And the denominator here is going to factor, let's see, we have 2x plus 4x, so we know it's going to have to be a 2x and an x, and we know the last one you have to multiply to get 2, so we have to use a 1 and a 2 again. Well, if we put a 1 here and a 2 here, we can see that these would give us 1x, these would give us 4x. Together, they do not make that plus 4x that's in the middle there, so that's not going to work. So let's try something else. So let's say, okay, get rid of all this. Now let's try if we put a 2 here and a 1 here. This would give us 2x, this would give us 2x, so that's going to be the combination that we want. And these are both plus, so we're going to put our addition signs in there. Let's get rid of this. Moving forward, now we can start canceling things that are in the numerator and denominator. You could rewrite this all in one fraction if you want, or you can simplify from here. We have an x plus 1 and an x plus 1. We have an x minus 1 and an x minus 1. Now we can multiply straight across. We have 2 times x minus 1 left in the numerator, and then x times 2x plus 2 in the denominator. We want to ask ourselves, okay, is that completely factored? Well, it looks like it, however, but when we look closely in our denominator, we'll see that each of those has a factor of 2. And we'll notice when we look back, we could have factored a 2 out of that denominator first. If you didn't, that's okay, we can address that now. So I'm going to put another equal sign, rewrite my numerator. Now, I know I have this x already, but now I need to factor out a 2, and then this is going to be x plus 1, we factor that out. So we multiply x times 2. Oh, and now we notice that they both have a 2, so we can cancel. And now we're left with x minus 1 over x times x plus 1. And last but not least, we want to look at a division problem. Remember, to divide two fractions, you have to multiply by the reciprocal of the divisor. The divisor is going to be the second fraction. Now, this one does not have a denominator, so we're going to put 1 there. Now it has a denominator of 1. So to take the reciprocal, we have to invert the numerator and denominator. We also have to factor. I'm going to factor this first fraction first. We know we have x plus 3 and x plus 3 for our numerator, and then x minus 4 is our denominator. Now we have to multiply by the reciprocal. For the sake of room, I'm going to do this in one step. So my 1 is now in the numerator, but now I have to factor this numerator. Well, we see that the coefficient is something other than 1, so it's going to be 3x and x, and now we have to explore what to fill it in. We have to get a 12 as our product. So if we do, let's say 3 and 4, that's going to give us a 3 and a 12, which isn't going to work. Or let's see, a 12 minus, they're still not going to give us the 5. So we want to play with our options to figure out what's going to work. Here we'd have a 9x on the outside and a 4x, which will give us a 5 because we want it to be subtraction, a minus 12. So if we have a negative 4x plus a 9x. Now from here, we can see what's going to cancel. We have an x plus 3 that cancels with an x plus 3. And it looks like that's going to be the only thing that cancels. So to write our answer, we get x plus 3 over x minus 4 times 3x minus 4. That is all I'm going to go over as far as reviewing 7.1 and 7.2. If you're having difficulties on the factoring portions, you want to go back to the previous unit and look at some of your notes there, or feel free to email me and I will be more than happy to send you some links to some videos that'll help you with your factoring skills. Look back at your notes. Let me know what questions you have. Have a good day. Bye.